Okay, so hello everyone. On this morning in San Francisco, I really think it shows a lot of dedication that you decided to join on Saturday morning. I'm in Berlin. It's already dark here. If anyone needs a proof that the Earth is round, here we have it. Here we have it. So my name is Maciej. I work in JetBrains in the IntelliJ Scala Plugin team. I'm something in between developer, advocate, and product manager. I write blog posts for release notes and go to conferences, talk about IntelliJ Scala Plugin and Scala in general. And today, in 2 weeks, and next 2 weeks, I will be giving this small course on functional programming. It's basically trying to merge. I'm trying to merge a few things here, talk about functional programming in general, because I understand that many of you may have already experience with Scala, or maybe experience with with other programming languages. So I would like to try to tell more about the whole functional programming as an idea, not necessarily about how it's implemented in Scala as a programming language, but like what you can do with it in general. Then I would like to talk a bit about Scala, why Scala is, in my opinion, a good programming language for functional programming, and also why exactly and what is IntelliJ Scala plugin, why I think it's a good idea to use it. So this course today will be pretty much about basics. I will try to go quite quickly through some very simple, those foundational blocks of functional programming. So if you know everything about it, maybe you can just I don't know, go make a coffee. But then this will be important to start with something more complicated. So I don't want to just skip over it, just maybe try to do it quicker than if it was a normal course for beginners. Yeah, and and at the end, I would like to tell a few things about the Academy plugin in JetBrains. This course is based and related to the interactive course that you can also install in IntelliJ IDEA and do by yourselves. What else? Yeah, if you have any questions, well, I will not be seeing you. Right now I'm looking at my own slide, but please ask it, and there will be like a moment when I will just stop, and that will be when we could just go into some digressions or details. Yeah, let's do it. Or if maybe you have some questions right now. Now I can go back to the Zoom and see the chat. How do I see the chat now?
Bottom bar of Zoom, the floating bar of Zoom normally has
Oh
the
yeah,
chat button.
okay. 2 new messages. Would the session be shared among the participants? The record session. So that's a
So
question for you.
I am recording this, and we do have a channel that I'll publish them on if Maciej doesn't has no objection.
Sure.
But when I'll publish it, maybe it maybe I haven't decided on the date that I will publish it on yet. So, but as long as Maciej doesn't object, I will publish them, and I will at the end of this meeting I will share the links to where to go and find the recording. And if you follow me on Twitter or social media, I
Yeah.
will announce it, of course. Yeah.
And the slides and the code examples are on GitHub. I will give you the link later as well. All right. Let's go back here. Okay. So I think I can say that many years ago, I think in 2017, I was on stage with Martin Oderski next to me, and he said that, well, functional programming is just programming with functions. And I'm pretty sure that didn't really think much about it, but it like stuck in my head. And while I started to develop this course in the slides, I decided to use it as the like a main motto. That there are many more complicated definitions. We often talk about functional programming in the sense that it should be more pure, like we shouldn't use any side effects, or there should be some effect systems that take care of it. We will talk about effect system later on the third day of the course, but I would like to stick to this, in my opinion, very pragmatic, very simple thing, that very simple definition that functional programming is simply when you have function as the first level citizen and you program with it. And programming with functions means that the same as if we have numbers as and booleans and strings as data types, and we can have references to some literals like I don't know, Tony Stark is a string, and Iron Man of the type string is a reference to that, and so on. We also can have our own case classes that are like those amalgamations of some simpler types into something more complicated. Then we also can think of a method or a function as the same form of data. Just the other types of data hold some information about the state of the world, but a reference to a function or a function holds information about how to transform what we get, what we give it. So the type of that multiplication function is actually both the type of its domain, the two numbers that I give it, and the type of the result. So it's like a pair of ints that is transformed into another int. And as you can see, we can just, it's on the same, on par, on the same level as any other type of data used in Scala. So for example, if I have, this is the function type, this is the domain and the codomain. So the domain is those two integers. The codomain is the result of the computations. So in a similar way that I can have a case class that has two fields, one string, one int, I can have another case class that has as a field that function type that takes two ints and returns an int. And so it's completely valid to have an instance bar that has a Tony Stark as a first element and a reference. So the name of the function is just a reference to this function of the second field of the bar instance. Yeah, so that's why I'm doing, like, why am I talking about it is because if we know in language like Scala, if we know exactly the types that go in any function and know exactly the type that goes out, that means that for every moment where we track our data through the program, we have meanings, we have ways to show what type it is, how they transform from one piece of code to another. That gives us a lot of type safety, which is some sort of a minimal documentation for us, and with help of integrated development environment like IntelliJ IDEA, we can then help ourselves to show exactly, okay, this piece of code is quite complicated, but since all the rules of static type programming are preserved, like in a language like Scala, then at any point we can see how our data is transformed between one type and another. That already means that a lot of bugs that in some other languages could go to runtime, in our situation are caught in compilation. Another thing that is also like very typical for functional programming, but it really is not something that is independent from that we program with function, but it kind of strives like is an effect of that we program with function, is the immutability. Instead of having a statement that transforms the data inside, if we program with function, it quite often means that we take some data and the result is a production, is something that is created. So the data that goes inside the function stays as they were, and as it was. And what we create is a new piece of data. It means that at no point, even if our computation is very complicated, at no point we change data from something to something. That again lets us be safe from problems that would arise if, for example, we access the same data from different threads. It lets us be lazy. That means that we don't have to compute things until they are absolutely necessary, because we are sure that the data doesn't change, so it doesn't matter at which point in time we will compute it. And there are a few other interesting results of that surety of that data doesn't change. One more thing, which I think we may say it's a bit redundant, since if we already say that we program with functions, but I think it's very important to stress, to talk about it, is that in functional programming, we often try to use expressions over statements. A statement, it's, how to say it? I would maybe put it like that. In languages that mostly operate on making changes to the data as we go, it's often somehow people are somehow motivated to put to put the way we program in one piece of code after another in one single block, because this way it's more readable what happens to the data. If I have some instance of a class that is transformed in place all the time, it's better if I keep it close to each other. Like we can see that for example here the number is we check what it is, if it's even or odd. If it's this one, then one day or another we make some we change it somehow, maybe not in this simple example, but something more complicated. And that seems pretty obvious, like okay, why wouldn't I do it? But the moment that your program starts to grow, when you're not the only person in your team, if this is not anymore your hobby project, but there are many people, with the very fact that people are motivated to write this way in statements and in blocks of code, means that the whole code base starts to grow exponentially into a lot of files, a lot of code that is getting bigger and bigger. And you may say, for example, that okay, if I'm the team leader here, I will look into that code. I will make people refactor it into smaller pieces and so on. That is true, but it also means that you start to be irrepressible, and you need to work on be that single point that make rules and make decisions. And that doesn't really work like that in bigger teams. So we usually have people who work independently from each other. We review each other code, but we try not to have this one single person that makes all the decisions. And that means that this way our programming language motivates us to write becomes more important, because it's instead of one making all the pushes, like pushing us into writing in a certain certain way. The language itself, the motivations that we get from how the language works, well, like what is the philosophy here, makes us do some things. Like, for example, if this is a language that prefers statements, then we will write it this way. We will write the code in a big list of statements one after another, even if we try very hard to do it in a readable, better way. So in Scala, in other functional programming languages, we try to, from the very start, to use expressions over statements. Expression is a smaller piece of code that means that that gets some data and performs some operation computation, and then returns the result instead of trying to, for example, here, instead of just making some operation and displaying the string number is even, number is odd. Instead, we just get the number, check if it is even or odd, and return the small even or odd string. And then the operation that is not pure, that is not inside an expression, is like only pushed to the end. Like we can, using expressions from the start, we try to put the not pure operations to one side, to some sort of like a walled garden, and the rest of the code is then safe to be written in this expression functional way. And of course, if we have a small piece of code like this function called even, then we can also transform it into a field, just like any other type of data. This even field takes an int and returns a string. Int to string is its type, and this way, like automatically, even if we don't think about it, the function becomes easy to reuse by other members of our team. In case if you write things like that, this is more complicated. The moment we want to reuse part of code, we often have to go to another person, talk if it's safe to like extract it to another method and then reused. So yeah, better to start with it from the very beginning. Yeah, let's go back. Yeah, and this small graph that I'm working on here is to show how different elements of functional programming help each other and create it's better to use them all together instead of just one separately from one another. So yeah, expressions over statements, that's basically the same as using functions for type safety, but also the two are very well connected. And then this is my belief that it also helps with readability. If I want to do something more complicated in the writing code with expressions, then I will try to think how I can slice the code into in a way that from some simple operation can be then put in one expression that will do something a bit more complex as a whole. And this, I can use it then as a small black box that does something inside. Then expressions that are a bit more complex can be again put together into one even more complex expression, and so on and so on. If done properly, it means that if I have a good name for that expression, if I have good names for parameters, if I have also good name for the types and for the result for the value that holds the result of my expression, that already gives me some kind of a minimalistic documentation, like a very readable code. So okay, why Scala? Why not something else? Like maybe I don't know. Maybe in C I can do the same thing. Probably not. Although I tried. Okay, so Scala is on JVM, of course. It's close connected to Java to the point that if we have Java on the side, if our product uses Java, or if our product uses libraries written in Java, we can very easily use it in Scala. And Java is JVM is the biggest ecosystem on Earth. So like programming in Scala, we already have access to all of it. We don't have to reinvent the wheel. We can just look into Java libraries if we don't have something that is already programmed in Scala, and we can use it easily. Similar to that is Kotlin. Kotlin also has an easy connection to Java. It's a bit more complicated to connect Scala to Kotlin, although that's also possible. Working in JetBrains, I like the IntelliJ Scala plugin I know it's written in Scala, but the rest of the IntelliJ platform uses both Java and Kotlin. We connect to both. So altogether, it creates like a one big family of programming languages that sometimes are at odds, but quite often they can cooperate. On the other hand, Java and Kotlin by themselves are not as functional as Scala is. We have on the functional side, we can say that Scala can be more similar to Haskell. I know that Rust is also implementing some functional programming principles, although because of the specific problems that Rust is supposed to fix, that it can be done as well as in Haskell or Scala. And also there is that big library called Arrow that is like a functional companion to Kotlin. So Kotlin with Arrow also like moves Kotlin more to the functional side. And I think Swift is also a good example of a programming language that uses some functional programming principles. So we have those two circles here. We have Scala and maybe Kotlin with the Arrow companion as languages that are both on JVM and also are very good at using FP in them. One rule that I would like to, so I'm generally I like many programming languages. Usually I work with Scala for 10 years now, but before that I used C, C++, Java, Lua. Generally one thing that I learned is that I prefer programming languages that are statically typed because of that minimalistic documentation I already mentioned. Type safety helps us understand the code, helps in refactoring by that if I change something, then the compiler and the IDE already can quickly tell me what else I need to change to make the code work. And yeah, that's type safety generally saved me from really a lot of bugs. Yeah, types are my friends, your friends as well. All right, I will be talking about some more of those concepts, not only those few, but I think for our first lesson here, that's good enough. Yeah, and the last thing from that introduction, why IntelliJ Scala Plugin? Before when I gave this lesson, I talked about each of those elements in separation. That we have a modern UI, we have the debugger, there's a code highlighting in the editor, and the code completion that is now both AI and just some our heuristics. There is also something called unused code analysis, which helps us check if the code is used, or if it is used, if it can be more like private, if the scope can be narrowed. Yeah, we have from a year and a half, we have AI Assistant, and we also offer build tool support for SBT, but also Scala CLI recently, and some kind of Scala support in Gradle and Maven as well. And we have something called inline hints that helps a lot with showing what types and what data show you how in the editor some additional information about the code you're working on. But instead of like talking in detail here, I thought recently that it would be faster if I just go to the IntelliJ IDEA and show you something else. So this is, you should see now the one of the code examples, function as data. If you click Alt Enter at any point in your code, you can get some hints. What can you do with it? If you, yeah, like this. If you click, for example, you go to actions here, you can see and start writing whatever link type info, yeah. So generally, instead of talking about all those things, I would like to invite you to just try to use like open IntelliJ IDEA on any fairly complex project you work on, and try to explore it, like what is possible with it. You can look through the actions here. This is I'm on Mac now. And this is my shortcut, Control Option Shift N for opening actions, and I can go through all of them, just checking what they are doing. I can also open settings. Settings are here, but I can also use on Mac Command and comma. And go to K-map. K-maps, this is my own customized K-map. You can choose one of the default ones if you want. Probably if you're on Mac, you will just get macOS. Or on Linux, this will be IntelliJ IDEA Classic, and on Windows the same. And similar as there on Actions, in the Actions window, you can just think, okay, so what I can do, maybe completion. And this will tell you, like, if you like, show you actions that are possible. Some of them exactly what you wanted to do, but also some others that might be interesting. And this way you can learn quite a lot about what IntelliJ IDEA can offer you, because we in the IntelliJ Scala Plugin team, we only work on a small part of the whole IDE. We only work on the support for Scala, but support for Scala also is like on top of some kind of a pyramid that below there's a support for all the JVM languages, and even below are all the possibilities or the things that IntelliJ offers to the developer, no matter what language, what technology you use. Yeah, and anyway, in a moment we will go back to code examples, and I will also discuss how certain things can be, certain features in IntelliJ IDEA can be used here. So yeah. Onboarding tips. This is a new feature that is mainly for beginners. If we create a new project, there's a possibility to create something like a small tutorial that shows some very simple features of IntelliJ IDEA as the person who goes through that tutorial starts to type. Right now it's just a few very simple things. You can also go to our YouTube channel and just search for IntelliJ IDEA on YouTube or IntelliJ Scala. And recently we started a YouTube video series about features of IntelliJ Scala plugin. All right. Are there any questions for now?
I just wanted to point out in the beginning slide, you kind of equated methods with functions. It's customary, but actually there are differences, and just wanted to point that out.
Oh, sure. Okay, listen. And it's going to the list of comments here. Must be okay. better testability, yes, better, easier concurrency, yes. The code examples I have are too simple to do something about concurrency, but on the last lecture we will be talking about system effects, so I will mention something about concurrency then. Okay, function of data. So Scala, if I go back to IntelliJ IDEA, Scala has a very complex and powerful standard library that basically relies on that. We can have methods, functions that are already doing something useful, and we can combine them into something even more complex and even more useful by using them together. So I would like to start with just a simple example. We have a user that has a name and an email. I already have 3 users here. Let me check if AI Assistant is on. Yeah, I think it is. That's why AI Assistant can very quickly help me with writing code. So now I'm kind of live coding, but not really, because if I just type here, then it gives me the whole of the sign. So okay, let's write a method that checks if that email of the user is valid. That should be pretty easy. I just go with user, email contains, yeah. So I don't know, it's kind of a joke that there are many ways to check if something is an email, and most of them are wrong and get more complicated if you try to fix them. And then at some point you just realize you were defeated, and you go back and just write that email is anything that contains the @ sign. So yeah, I kind of understand it. Maybe instead of contains here, I could instead use count. And so email is anything that contains just one count character, but here it tells me that it requires, okay, so it should be like a C, that C is equals this count character. And the number of such, so email string in Scala can also have a method that checks how many characters like this are inside it. And if it's 1, then we say, okay, this is a valid email, no more checks needed. Okay, we can pass this function to filter. As you can see, okay, all of those 3 users have valid emails now, but let's say that Garfield doesn't anymore. And I can use users, exactly, filter is email valid. So filter is a method from the Scala standard library that takes a thread that is takes a function that checks for every element if in the collection, if that element fulfills some requirement. So in this case, to make it more readable, I could write that the filter method takes for every user in the users, it passes that user to the method is email valid. This method checks if the email is valid according to this rule, and if it returns true, then okay, this is a valid user. So this is a function, and it can be written as a function. I can just write val is email valid fun, and this will be a function of the type user to boolean, and basically it's exactly the same as before. So yeah, and the only difference is that maybe this is maybe a bit unreadable, but I can do it like this. So instead of having a method, this is exactly the same code written as a field. And of course, it can be used for this very same, in the very same filter this way. And in fact, it can be, as the AI assistant already told me, it can be also like this. So the name of the method is email valid is already a reference. And this is equivalent to this value here that can be also passed to the filter. Or we can use an anonymous function, which is simply like inlining. So as you can see here, I can take this and put it here. And this is also equivalent to both those those methods. One more thing. One more thing is that lambdas, so like this is a lambda, can also take values from its scope. So for example, okay, Garfield is someone who doesn't have a valid email, but I can do it that if user name is always valid name or user email counter. So this will basically mean that Garfield is also a valid user simply because I have this value here. It might not be the best good practice for programming, but yeah, it's possible. So all this, the fact that I can create functions and add them to like put them as parameters to other functions and then probably also put those functions as parameters to yet other functions means that using the Scala standard library and the collections in it, I can practically do lots of things that in some other languages would require me to use some separate third-party libraries or write that code by myself. So again, we have a user, we have a name and email. We have three of those users. I can just write user seek this way. Joe, Garfield, and Felix are our users in the sequence. And we can try to sort them with, for example, user seek sort with and method sort with. If I just, this is for you, just go to implementation. Okay, so yeah, this sorts a sequence, and what it does, it requires me to put as a parameter one parameter that is a function that takes two elements of the same type, and it either gives me true or false depending on which of those elements, those two elements, should be in the front. So we are not here anymore. Collections. Yeah, so here we have user one, user two, and sort with by the function that just checks which name is more to the front of the alphabet. There are also things like implicit ordering that we don't have yet. Because for names, like if we only, for some of the data in Scala, it's possible to just sort because that data already knows, like that is sortable. For user, it is not because I just created it. What I would need to implement an ordering for user, and that ordering is an implicit parameter, implicit meaning that I don't have to give it explicitly by typing, but I can tell the compiler, okay, if you ever find yourself in a situation when you need to get a parameter, implicit parameter ordering user, then please use this, or that the ordering that I'm implementing in this place. And the compiler will look in the scope for such an ordering. I won't do it here now, but instead I can just show you users sorted by thought by that simply if I have a user, I give create a small function that takes that user and gives instead something that is already thought up, in this case, the name of that user. And since I'm only once using the user reference here, I can use a wildcard instead, and Scala will know that this underscore means that I want to use user at this place. What else? We have maps also. Thank you, AI assistant. A map is in fact like a sequence of tuples, but implementation beneath it is different. It's a hash map, but for all the reasons that we can think about it on some more abstract level, we can decide that this is exactly the same. So yeah, like this is the key, this is the value. If I have a sequence and I turn this into a sequence of tuples like this, so user to a tuple of the name and the user, then that's already the same as the map. And just let me see. Okay, and yeah, I can also take that map and turn it back into a sequence of tuples. Filter we already discussed. Other methods that are quite useful are users seek find, for example, like this. So while filter would go to the whole list of like the whole sequence and check for it would take as a parameter a function that would check for some requirement, and the filter method would give me a sequence of all the instances that fulfill that requirement. Find method looks only for the first one. That will be interesting a bit later if we, I hope we will have time today to also talk about early returns. That means that if I only need one element, I can use find instead of filter. Of course, we also have for each. For each is like a method that actually does something. It doesn't return anything, so I can print line the name of the user, for example. And one thing that is in Scala very often used is user seek map, for example, this way. So if we have val names user seek map. So the transformations are a very important part of the Scala collections library, and map and flat map and fold left and many methods like that you can find in the standard collections are used very often everywhere in Scala code. This one simply takes like for a collection of users. For every element in that collection, transforms that user into its own name and returns the result, which is a sequence of strings of names. I can, for example, just explicitly say what type it is. Flat map is something, but you can already see that if we have a sequence of users, if I map it to a sequence of names, then this is a one-to-one connection. For every user, we only have one name. If I have, for example, I don't know, if I have first name and last name, and if I try to map users into those two, then what I will get is a sequence of like a tuples or sequence of sequences. That inner sequence will be will have the names. So the total number of those inner elements will be always the same as the total number of the original elements. Sorry. And we can sometimes, very often, actually we want something more flexible, something that would give us like a few elements for only one element that was original, or the other way around. We can think that one element that is original would produce many elements, or one element, or maybe 0 elements, and still we want that sequence of original elements to be transformed into a sequence of something that is of unknown size at the moment of transformation. So what we can do here, for example, we can have a class or case class conversation. Case class is like a, here I also use case class. So this is what we have in Java, in New Java as record, and in Kotlin as data class. So this is a class that has already certain methods implemented by the compiler because we want to make it easier to use as container for data for those fields. So usually we use case classes only this way. Like you hardly ever should see a case class that also has some methods that use those that work on the user. Okay, so we have a case class user, and now we have a case class conversation. A conversation can have a title and a list of participants. And let's say if we have those 3 users, we would like to create a conversation that is, sorry, let me just take a look. Yeah, let's call it, already. Okay, so let's call it Joe's Convos. This is a list of conversations that Joe has with any other user. So we have users that from the user seek, we take all users that are not Joe, and then we map that user to the conversation between Joe and that user. But if we would like to just have all the conversation like this, not only for Joe, but for everyone else, we would do it by just writing users flat map. That's right. Users flat map. And for every user, we want to again look into the list of users. We want to take another user and then create a conversation between those 2. And one more thing that we should do is that we would like to filter not. Let's see, filter not. Name of that second user shouldn't be the same as the name of the first user. So we don't want a conversation between Joe and Joe, Felix and Felix, Garfield and Garfield. We want all the other ones. So you can see that this will create 2 conversations for each user here. And together, convos will have 6 conversations. What we can also do here, this is a small feature that we worked on in IntelliJ Scala plugin called X-ray. Like Scala has inferred types and inferred and parameter names and so on. You don't have to write them, but they are still there in known to the compiler. Sometimes it's useful to know them. So we can, for example, write them explicitly, like here as type annotation, or here in convos. But if we write too much code like this, the code again starts being unreadable. Our solution in IntelliJ IDEA for this is that we have those inline chains. I have already them turned on for parameter names here, but I don't have them turned on for inferred types, for example, convos. We know that this is a sequence of conversations. I can click twice, type twice command here, and this will show me the type of the field convos. But if I just let it go, then it will disappear again. And the same goes for example, parameter types, like here in flatmap, and for certain other things. Okay. Flatmaps will be also important in a moment. But first, I would like to go to the very typical thing that every junior can find themselves to do on the during the interview. That is to implement a FizzBuzz, and let's try to do it in a functional way quickly. For example, and we'll for example, we can have a FizzBuzz that so for every number from 1 to 100, let's say, we need to turn that number into a string, and it was already code completed for me. Okay, if a number is divisible by 15, then we write FizzBuzz. If the number is divisible by 3, then we write Fizz. If the number is divisible by 5, we write Buzz. And otherwise, we return the number, which also can be simply a string. And then I don't have to have this, but just wanted to showcase that in Scala, it's possible to have union types, so we can return from this method either a string or an int. And yeah, so we have our numbers from 1 to 100, and we can use a method called fold left that will create our fold do it like maybe a bit differently than here. Fizz buzz list will be number of starting from 1 to 100. We'll create a list of either int or string for every number, and we start with a empty list, and then for every such element, so fold left takes one element, applies some transformation, and add it to what we have here, what's usually called a calculator, an accumulator, sorry, and that will be like let's say this is our accumulator, and is our number from 1 to 100, and we add to the accumulator appended the result of a transformation, and the result of a transformation is just FizzBuzz of n. Okay. And our result here,
there is a question in the chat that's interesting.
Yes.
If you don't mind me interrupting you.
Sure.
How do you handle two different return types into a string, for example?
Yes. So this is not yet done here. FizzBuzz list right now, if I can just add an explicit type, not user sequin, this one, not user ID, but int. And so what we have here is a sequence of either ints or strings. I don't yet know which ones. What I need to do now, before I print it out, is to actually find a way to get every int and change it to string, and then somehow put them together in one string. AI Assistant already hints that I can do it with one method called mkstring. Mkstring takes every element of that FizzBuzz list, implicitly turns it into a string, and then join them all together with this. But we can also do it a bit slower and step by step. For example, this way. bus list, and we can map each element. Okay, exactly. Also, assistant has here. So we can have two cases, right? For every element of the bus list, we have we can go through either this way, in this case here, where the element is an int, or either this case here, one element is a string. For strings, we don't have to do anything. For ints, we simply now to turn it into a string. What it means is that ref will be now sequence of strings. And this one can be now, for example, joined together with commas. So let's try. So yeah, 1, 2, for 3 it's fizz, for 5 is buzz, for 6 is fizz, so and then for 15 it's fizz buzz, and so on and so on. So what we did here is we used a match case or pattern matching. First, simply in this a bit weird form where we don't really care about the exact number, but we use this n here in the if clause. So and only depending on this we return either a string or the number itself. But then we have this fold left that takes the each element of the number from 1 to 100 and creates a list of integers or strings from it. And then again, we used map, this time in a bit different way. The cases here, which normally would be used to just check if the value of that element fulfills some requirement, like is smaller, bigger, maybe we can also give it to some other function that will return some value for us. But we can also in Scala use map or match or other other methods from the Scala collections library to check for for the types. So if the type of the element is int, then we do this. If the type of the element is string, then we do this. The same goes if we have some type hierarchy. For example, if we have like a, I don't know, user that can be a pro user or just a beginner user, and we can have subclasses of that main class, then we can also use this match or map and perform different operations depending on which subclass or which trait. Trait is like a interface in Java. Which trait is it? So yeah, and we can also make it even more complicated and put those together. Maybe not, maybe like this. So this will mean that if our element from this bus list is an int, and if that, let's say, because otherwise 7, if it's divisible by 7, then we write this, and this should also easily work here. Yeah, and for 7 we have here. So this is, of course, a very trivial example, but I hope this already can show you how in just adding like one line of code in Scala, using those principles that we talked about, can already add something interesting to your logic, and you can very easily read it, and you can very easily add to it, make it more complex. Okay, and maybe, yeah, I already talked about X-ray, but just wanted to show you because in Scala, in functional programming in general, we use it in a way that something that goes to one function, one method, then returns, and then we can have in collection like a transform one collection into another. So on that the result of that collection, we can call another method and then another, so we can chain those methods. And for example, in using X-rays, we can show how the types change from in those intermediate stages. For example, here we have a sequence of words, I transform it into a view of sequence of words. A view is like a sort of a lazy sequence that is not yet evaluated. Whatever operations I do on view are evaluated only when they are needed. So I turn the sequence into a view, then I map that string to the length of a string. So the sequence view of string changes into sequence view of int. Then I perform some other operations on it, and at the end I just get some kind of a number or 0 if that number doesn't exist. So I can already see one step after another how the type of those of the collection changes because of the methods I used here. Okay. Yeah, another topic is total and partial functions. But first, any questions to what we talked about? A bit difficult for me to turn on the chat.
There's two questions on
Yes.
Twitch. First one is, could you simply omit the n match here when you were doing that pattern matching example just before this? Where was it? Yeah,
So I was
yeah, that
here.
one. Yeah, the question was, could you simply omit the n match here?
The n match in here.
Yeah.
No, because so map. I was basically okay. So what I'm talking in this moment about is exactly the difference between total and partial functions. Map requires me to give you give as a parameter a total function, because what I'm doing here in a
You made the line number 9 is what the question was about. It's just been clarified.
line number 9. Oh, here. So here is a bit like okay, maybe using match case here is not like the best practice, because if I do it like this, it would also work. But so yeah, so this and here. But basically, as you can see, I don't care about what that n is at this point. What I care is I add this if clause, and that basically turns my match case into just like a sequence of ifs. This part could be written instead as if n 3 equals 0, then buzz, else if n. In fact, I should start with n15. Okay, so if n15 equals 0, then fizzbuzz, else if then fizz, else if n5 equals 0, then buzz. So yeah, so it's like bam, bam, bam. Usually we use n match case when we already want to do something on here. So if I wanted to write it like this, but that would work only for one element, right? If I want, if that n is 15, then we go through this case. If n is 3, then we go through this case. If n is 5, then we go through this case. But if I want something a bit more complex, with like not only for not only for 15, but for every number that is divisible by 15, then I need to put it in the if clause, or I need to create a method, and for example, I will talk about that later. There is a way to put some more complex logic also here, but that will require a bit more theory before. So anyway, what we do here is just use match case as instead of if else. Here instead, on the line 27, 28, we actually just check something already in that case part, in this part. So then this is important. This looks like this. Does that answer the question?
Also, let's see. Yep, yep. Thanks for that. He
All
does
right.
have one more question, and that is there a way to show the types like you can with metals?
Show the types.
Yeah.
So the types are, if for example, I just go here and write, oh, maybe I already did. So you can see the types in you can see the types here in just a in Control T. So that's Control T. I don't remember the shortcut here, but if I just okay, let's go to key map. Type info. Type info is Control Shift T. So if I go here and just Control Shift T, that's unit. Oh yeah, because it's storage, of course. So yes, it is unit. But let's go here. Control T. That's an option of user. Option because find may not find the element in the collection that fulfills the requirement, and then I get a subclass of option called none. If I find the requirement, if I find something that fulfills the requirement, I will get some of user. We will get to it later. Anyway, for every element here, wherever I put it, I can just click type info. In my case, that's Control Shift T, and this will show it in a pop-up. But I can also use it in the X-ray, in the inline hints, this way. So it will just show inside the editor like that.
Yeah,
Okay.
I've got on switch in the X-ray example. You had IntelliJ show the types on each line of a long chain of operations. That would be really
Yes.
useful. It's also available in metals.
Yes. So
there you go.
Actually, in IntelliJ, it was our team in Scala that came up with it first, and now they added it also to Kotlin and maybe also Java, but it started with Scala. Actually, I wanted to talk about total and parcel functions, and this may also be an interesting case for that. But let's go here and talk about the theory for a moment. Okay, we have a function, for example, multiplication, that takes two parameters, two ints, and produces another int. And we know for sure from mathematics that every two ints can be multiplied and will produce another int. So the function is total, like for every for anything that goes as in the domain, sorry, this will produce a valid result. For every possible combination of parameters, it produces a valid result. This does not work always. The easiest counter example is the divide method that also takes two ints, but it can't produce an int for every every possible combination of parameters. And I'm not even talking about that for that we will have not an int but a double. For example, if we can force the diff function here to actually produce an int even if we have like a 5 and 2 and the result is 2.5, but because we want an int and not a double type, then we just say, okay, let's just cut that .5 and just return 2. That's okay. The bigger problem is that when the second parameter, y, is 0, the function will return an exception, will throw an exception instead of actually returning something valid. So we could say that the result part, the codomain of the diff function is not really an int, but like an int and or an exception, right? Like if we don't count that exception as a part of the codomain, that means that our function is not total, it is partial. It only works for some subdomain of, yes, for some subdomain. Not, we can think about transformations like those function mul or diff or practically any other on some level of abstraction as if they were all map functions. Like they take some parameters and they map it to something from the codomain set, like the domain set is mapped to the codomain set. And in case of partial functions like diff, we don't have it for every element of the domain. So for example, for 4 and 0, we don't. There's no valid number that we can map those 4 and 0 to. That's not always, that's often a bug, and that's often a mistake, and we shouldn't do it. But in fact, in many programming languages, Scala included, that's actually a feature. Because there are methods that rely on that. We will give them as a parameter a partial function, and they will produce a valid result if it's possible, and they will, and if not, if it's that partial function doesn't work for the element that is given to that method, then they will do something different. So they like completely know that they are aware of that this is a partial function and it shouldn't actually work for everything. If it doesn't, we handle that. We know what to do. So in Scala, those methods, that one of those methods is collect. And collect may be called also filter map in some other languages. It means that collect actually works as faster and like a more concise connection of first filtering our sequence of elements by filtering only those that are valid for the given operation, and then map, and mapping is actually performing that operation. So for example, let's say we have cats in a bag. They are of different colors, and what we want to do is to have the names of the cats that are black. So we first filter, we create, by filtering, we create a new collection of cats that are only black, and then we perform a map operation from cat to the name of that cat, right? But we can do exactly this by using the case of the method collect and using the keyword case in Scala. That means that we combine filtering and mapping in one, because case cat, if cat color equals black, then return cat name, is a partial function. That also was what was happening here in the FizzBuzz example. FizzBuzz list is a sequence of ints or strings. And what I did here in a map is I covered all two cases, right? Like by covering a case where the element is int and by covering the case where the element is string, I practically like told the compiler, okay, all cases are covered. That means that the function I gave to the map method is total, and map needs a total method. If I, for example, did this, then actually let's run it. What will happen? Yeah. So the problem is that I can't. It won't work because one of the cases is not covered. That method is only partial. What I can do actually is to change this map to collect. Collect. Now it should work. Now it works, and what it does, it displays the numbers that are not divisible by 3, not divisible by 5, well, and by extension, they are also not divisible by 15. Because I used the partial function that works only for those elements in the Fishbuzz list that are ints, and ints are those that were not transformed into strings here. So, hooray. Yeah, so basically that's it from the slides. What I can show you more about partial functions is that, let's say, yeah. We have something, I have this user data. This may be a bit more practical example. This is, we have a case class user data that has some user ID, string, like name that is type of string, email, and age. And also we have that small database of users here, and the map of parents. And this is a map of user IDs to user IDs. For this element, if there is a user with this ID, then the user with this ID is the parent of the first one. Of course, for some elements in the database, we don't have information about their parents. And also, as you can see, there is an error here. It's shown that the user with ID 4 has a parent with ID 12, but there is no user with ID 12 in the database. So what we can do what I would like to do in here is to first take all the database, that is a sequence of user data, and then first I will just, for every user in the database, I will get the user of that EU ID. What will happen here is that, yeah, so already IntelliJ tells me that something's wrong here, because using the method get on the map will only give me a valid result for those elements that are actually in the map, and for all others I will get none. So here what we have is a sequence of options of user ID, not sequence of strings. So what I can do now is to use the method collect. It's actually pretty, sorry. Yeah, so it's actually pretty common to use collect for options instead of, what I want to do is that if I have a valid ID taken from that map of parents, then, and if in the database there exists a user such that it has an ID that is my parent ID, then I want to take the name of that parent. Yes, now it all works, and if I if I just try to do this, I should also see. Okay, only this. All right, so this is our parent name. And if now I write the main method, I can do it probably here, but I will probably need to, yeah, main def. I will probably need to go to the collection or collection flat map. Now, which one or oh, this one? Okay, so there should be only one main method in the data in the project. So I need to comment out this one. Then I'll go here and oh yeah, and also add type. Yes, thank you. So yeah, so what I get here is the name, all the names of the parents of people in the database. And you can see that even one person, Sofia Martinez, is displayed 3 times. But we already, by using collect here, we were able to avoid both 2 traps that user data here. So first problem could be that some of those users here don't have a parent. So if in that case, this would return a none. And in the collect, we already say that, okay, we are only interested in a situation where taking an element from the parents map will be valid. We will have some ID from the parents. And the second problem is that for this one user here, with the ID 4, Emily Johnson, then in the map we have an ID that does not exist in the database. So without the second part of without this if clause here, we would get some ID, but that ID wouldn't be here, and this would also fail. But here we have that covered. So like both cases where something can go wrong are already covered. Collect is actually very often used in situations like this when we want to do something only if if the data is valid for us, such that we will be sure that there will be no exception thrown, no error when we actually perform that transformation, which is in this case taking the name of the person with this ID from the database. All right. Any questions?
No questions.
I see that someone already answered that. Yeah, this is AI assistant from JetBrains. Actually, I can also say a bit more. Like in my case, I use OpenAI GPT for all. There is a possibility to use a different one also from JetBrains. You need to have a separate license to be able to choose from them. But there's also a possibility that if, for example, you're a company or you yourself, if you run a local model, you can connect AI assistant to that model.
I have a
One, yes.
question. Yeah. I don't know if now if this this meeting is the right time to ask, but it's about just programming languages at a higher level, the differences between them. Around 2014, I think Scala was really getting a lot of attention, and since then, other languages have become more exciting. My question is, it seemed like it might take over Java at some point. Then I know LinkedIn actually they started switching to Scala, and then when Java came back with new features and new release cadence, they started to move back to Java. So I'm just trying to wonder what is how do I say this now? What 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 is the most compelling reason to use Scala? I think type safety is one big thing, but I think where might that be better than, say, using Java with its modern features? I'm a Java developer. I've not used Scala before.
Okay, thanks for the question. So, okay, actually I stopped sharing, or do I? Sure. So let's go back to this one slide I had before. Okay, you should see now that slide with how different concepts in FP support each other. Do you?
Where in this slide?
Do you see the slide with all those concepts?
Oh, yeah. And
arrows
by the way,
between
this is a fantastic diagram, by the way. I've taken a screenshot. But yes.
So basically, Scala is of academic origin. It was designed from scratch on EPFL, École Polytechnique Fédérale in Lausanne, in Switzerland, by Martin Oderski and his team. And so it's a language that is designed from some basic principles up. And this means that the features of Scala very well fit with each other, and they can have this synergy that one concept actually helps with another. We saw that already for a moment, that we can use the match case, but we can also use cases for inside a map or inside a collect if we want to use partial function. Generally, match case is like the feature in Scala, that everything can be pattern matched. You can also see on this slide here that we have those kind of a way to use exactly the same the same concepts to handle and to help ourselves with different other features that are in many different languages, but in Scala they are like very well. I would say that they are at the core. We can, for example, because of immutability, there is a large number of ways to use that immutability for laziness or for thread safety. In certain, like in Java, even though since a few years ago the new Java versions start to have this better pattern matching and using functions as also a way to as a first-class citizens, it is still like slow, and it's not it wasn't there from the beginning. So we still need to have this backward compatibility, which means that then certain things in Java probably will never be possible because we would need to break from how it was done before. I basically I like Scala the most because of how since the features like this, like immutability, pattern matching, type safety, how they were already there from the beginning, it means that the language is more concise, still readable, even though it's concise. And you can quite often find ways to write only like a little piece of code, and in this Scala idiomatic way, and it will already do a lot. Like things that in Java require quite a big piece of code, in Scala quite often can be done in one line.
Hey, Mash, can I add something more on Scala? Because I've been in the Scala community since its inception. Okay, I got out of it, but I'm coming back. So Scala mainly is being used for collection management. In my couple of companies where I worked on the AI projects also, I'm just trying to refresh. The reason I'm doing is just refresh all my coding skills. I'm moved up in the hierarchy. So it's mainly used for collection management and heavy big data processing. Okay, and in my current company also, we are very heavy on Scala and Spark for financials data processing with respect to monthly closure activities for enterprises.
Mm-hmm. Yeah, I worked on I worked in one company that for a few years used Scala in an Android application, and right now probably no big application on Android uses Scala, but back then I thought that this is really a good fit because on Android you can have data coming from very different sources, from the user, from the internet, from the Android itself, and we were able to in a very sophisticated, complex way to handle them by reusing the same code and in the same time it was like thread safe and type safe. So yeah, I
So
really
to answer
like that.
Sridhar's question, right? Sridhar, we have mainly used for collection management.
Yes.
We have interchangeably used Java and Scala together. And when it came to collection management, we just moved it to Scala because it's much easier to manage a large volume of data in Scala, even though Scala is written on top of JVM. Okay. But still, Scala does much better job when it comes to collection management. Even if you take the latest Java code, it still has a problem when it comes to collection management.
When you say collections management,
Yeah.
do you mean physical collections like libraries? But oh, okay, interesting.
Okay, so yeah, because mainly for the big data processing, I've used Scala with, like I said, on the AI project with my Hadoop infrastructure. We literally use Scala and Spark. I'm still using Scala Spark in my current company also. Okay, we are just a team that just does that only. We have a hardcore Java developers who also like, yes, let that code remain in Scala. We don't want to bring it back into Java.
Yeah.
I should also just share one tiny thing. One company I worked at, again 10 years ago, they used Akka and for actor-based concurrency. The code in Java was so cumbersome, but doing the same thing in Scala was just so much more elegant. Unfortunately, like somebody said in Salar said in chat, staffing is a bit of an issue. But yeah, it's one of those things that academically it's very elegant, and the industry and politics is messy. But thank you. This is all great information.
That's true. Yeah,
So-
we have a very elegant language that has a problem with getting through to business.
And you're
I'd
true, by the
like to.
Sarah, you're right. I'm still struggling to hire Scala engineers in India. You don't get that many people.
So since we mentioned immutability as a key feature of functional programming, Java does not really have proper immutable collections, and Scala has both mutable and immutable collections. So if you go through the standard library, there are quite some differences, and Scala has many benefits here. Also the language itself has features that Java does not have and probably will never have, like implicits or givens.
Yes, right now I'm trying not to talk about the difference between Scala 2 and Scala 3. In Scala 3, we have very many new features, like it's givens, enums that we will go back, we will talk about later, but that's a pretty basic one. But yeah, I think another thing in Scala is that the language really is kind of fearless. It adds a lot of features very quickly. Some people don't like it because it means that the code can get very messy because some parts of it use new features, some parts don't. But as we can see also in the whole JVM ecosystem, Java and Kotlin kind of also implement things that are already in Scala. We kind of are the experimental ground here. One more thing that I wanted to talk about today, quickly, is called is that we can also return functions from functions. So apart from that, we can use collections where we give some kind of function as a parameter and get another collection that is transformed by that with the help of that parameter function. We can also, since a function is a first-class citizens and it's treated exactly the same as any other type of data in Scala, we can also we are also able to create a function inside another function and return it. So this is just like a quick, fun example here. We have colors. Colors are here of an enum, black, white, ginger, and these are colors of a cat. So we go back to functions, return functions, and we have some cats that of them with 3 names: Fluff, Shadow, Garfield. What I would like to write here is a method that I would call a cat generator. Cat generator is a function that for a given, let's do it like this. We have cat already. Okay. For a given name of a cat generator is a method or a function. It can be both. Both names are okay. So it's a function that returns a function, and that new function takes no parameters. And when called, that new function will create a cat of the given name and of some random color. Actually, I don't want to have it here. I prefer that this part goes in here so this way we will see it better. So, and well, I can even, but that's probably a bit less readable. If I have, if my function is just an expression, just one expression, then I don't need the braces. So yeah, and this is how I create a function. This part here is my list of parameters of that function that I will return, which is empty. And for that empty list of parameters, I created this cat, taking the name that I given already in the cat generator and taking a color randomly from that list of colors. There are only 3 colors. And what I can do here now is basically create a generator, because that was just a method that that creates a generator. So now, for example, we have one generator that creates a cat of the name Fluff and some color, and another generator that creates a cat with the name Shadow and some color as well. I can now again write a main method. By the way, this is a template. If you write if you write a certain word in IntelliJ IDEA, if that word is already in a map, in a dictionary in the settings that is associated with the function template, then IntelliJ will display a pop-up and tell you, oh, okay, I can do it for you. I have this template. You can do that if I go here to settings. By the way, because there are so many possible things that you can do in the settings, then you can just search it here instead of just going to all the tabs. You can just type what you want to find, and settings and IntelliJ will try to help you. And you can go to Scala, and you can see you have if you write apply, IntelliJ will try to write an apply method for you. If you write main, it will write the main method for you, and some other methods as well, or some pieces of code. It doesn't have to be a method. It can be like a comment, or here we have some kind of an XML that you can use. Then you just use tab or space or enter or whatever to turn your just the name of the template into a template, and you can add your own, or you can modify what you see here. So now I just write main here, and IntelliJ tells me, okay, I can generate the main method for you. I decide to do it. And now I have a method that will use those generators. Every time it's called, it will first call the generator. That generator is created here. And only when that method is called, that's gen1, it will create a cat of some random color. So if I just call it now, that's ginger fluff and black shadow. But if I call it again, then that's a white fluff and black shadow as well. Probably shadow also can be of a different color. So as you can see, we can have a function creating a function. That function can possibly also inside itself also create a function, and so on and so on. It also works the other way around. We have two ways to do it. One is called wait, I'm taking it too far. So let's do it like this. A normal way to sum two numbers xy would look like this, but in Scala we can have we can just separate it, and we can have two lists of parameters, one for the x and y for the one for y. This is exactly equivalent to this, so they will work the same. It doesn't matter if we have comma as a separator between two parameters, or if we put them in separate parentheses. But if you can see that this works, right? This is just the same two parameters. Then you can also think of it, okay, so what will happen if I just write sum of 2, right? Because if I write sum of 2 and 1, then of course it will just sum those numbers, it will give me 3. But if I write 2 and 1 like this, the same will happen. It will just use this sum 2 here and will give me 2 plus 1, so 3. But what if I do just that? It will also work. Only the problem is that it will not create the result that is int. It will create not user ID, no, it should be int to int. It will create a method that will take another int, and only when it takes that int, it will create a result. So if I do this and then write res1, this will give me 3, because what I got from here is this generated this function generated a function that I called res, and that function already have the first argument, that x, and this argument here is already used, like the constant 2 is used here, and this 1 here is actually what goes in this in y. So this 2 plus 1 gives me 3. In fact, I can even write it like I can also write it like this. So what I have here is a function that takes a method that will for a number will create a method function. It takes a function that will for some number create a function that takes a number and only then creates a result that's also a number. So yeah, we can write that this is a style that is more like in Haskell. We can but it's still usable, even though this is probably the easiest to understand. So yeah, we have two ways. This is called carrying. This is the process of converting a function with multiple arguments into a sequence of functions that take one argument. And also there is a partial application, which means that I just have a function that already has more than one argument, but I only provide one, and in the result, what I get is a function that has already this one argument set, but I can still provide other arguments to it. It's not super practical I think, but it can sometimes mean that your code can be further reused even more than maybe you suspected. Okay. Yeah, that is all for today. But we still have time for some questions if you want me to go into detail about something.
It's Shrida again here.
Yes.
Yeah. Again, this is not really relevant to what you're presenting, but just Scala. I'm interested in languages that have compilation to native executables, and I know there's Scala native. Do you have any
Yes.
experience with it? And when it comes to cross compilation, that can be there aren't many languages that do it well. I'm wondering if you have experience with it, what you think of Scala native, and anything you can share about that.
Well, I didn't do anything practical with Scala Native. I think it's a very nice, project that right now is already quite mature. I know that they really they work on a subset of Scala, and what they support, the parts of Scala they support, works pretty well. You can have both pretty good performance and smaller bytecode, because you don't have to use the whole garbage collection on JVM. But for example, it works only for that supported Scala subset. So if you use any Java library in your project, you probably can't use Scala native for that. Also, some Scala libraries are not supported. Another way to compile to natively in Scala that I used actually is GraalVM native image. And that works, that is more robust in the way that you can use any Java library and any Scala library in your project. It has its own issues. For example, if you use reflection somewhere, but in Scala itself, reflection is hardly ever used, so that's not a problem for native, for projects that are only in Scala. And the result of GraalVM native image is often bigger than Scala native and maybe a bit slower. I'm not sure, but anyway, yeah, it's possible, and I like it a lot. Anything else? If not, then I would like to show you one more. Just go to JetBrains Academy. Oh. Yeah. So this course is connected to the plugin that is also developed at JetBrains called Academy. When you go to the settings and plugins here, you can find both the Scala plugin and Academy plugin. I have them already installed. If they are not installed, they would be in the marketplace. And if you have them both installed in your IntelliJ IDEA, then you will find the tab Learn and Teach in the file. You can browse courses. and you can find functional programming in Scala. Also, it might be not yet started. You might need to download it, but if you have it, you can go here, open it, and that's a course with lots of descriptions, lots of what I talked today, and will in 2 weeks and in 4 weeks. And it will just go through to those topics. It will show you some code that will and ask you to fill some exercises. Of course, you don't have to do it. You can just read the description and just make your own exercises here, your own experiments. But yeah, the whole thing is divided into, I think right now, 7 big modules, and each module is full of additional smaller sub-modules with a lot of examples of what you can do in Scala. Yeah, so that would be it for today.
I have one quick question, please.
Yes.
Yeah. So till advanced Scala, like it's okay. Like it's very it's easy to comprehend and apply in projects. But if we move towards like more abstract like cats or cats effects or lens stuff like that, it's getting more complicated. So what is the best way to like learn and practice and to understand those concepts which are more abstract and but still widely used in projects?
Yes. So this course and the plugin and the interactive course from JetBrains Academy, at the end we touch the subject of Cat's effect and how to use it, what it is exactly. If you want to find more about more abstract things, I highly recommend just YouTube. And on YouTube you can find Dev inside me. That's one of our not devil. Dev is why
Whilst
do
you
you
find it, I do want to say that to use Scala, you don't have to learn Cat's effect or anything like that. Those are
You don't.
optional if you wish to. And in a lot of ways, yeah, if you start with learning those, it can be overwhelming. So start small. You don't have to use every feature and library to be productive and happy with Scala, yeah?
I see. Okay, thank you.
Yes, but anyway, if you want, there are, exactly. Rock the JVM is a very good Scala teacher on YouTube. The others are, oh yes, Dev Inside You, not Inside Me. So yeah, those 2 channels, Rock the JVM and Dev Inside You, are 2 main Scala teaching channels on YouTube. And there's like really a lot of videos from both of them. And they mostly touch more complicated subjects. So I decided to talk more about basic stuff in my on my own channel and in my own lectures, and just leave it to them if you want to go with something more complicated. But also, yes, you don't have to use Cat's systems, Cat's effect. You don't have to use effect systems to be to have a career in Scala. Akka is another possibility for a big ecosystem that is used in production in many companies. And there are also libraries and frameworks that don't really go that much into pure functional programming. They just use those basics we talk about here to improve on what is more like Java, but yeah, but more type safe and more concise and readable.
Awesome. Thank you.
All right.
And before I forget, we do both online and in-person events, so do make subscribe to our Luma if you haven't, which I assume everyone has. And I can't thank you enough, Maciej, for doing this talk. And the next one's in 2 weeks, right? Hope everyone's...
Yes, exactly. Exactly in 2 weeks.
If there are no more questions, then thank you everyone for joining. Great questions, great attendance, and let's keep the conversations going between now and next 2 weeks. And have a great weekend, all.
Jette, thank you very much for this opportunity.
Thank you, guys.
Thank you.
Goodbye.
Yeah.